Chapter 5. This whole chapter is going to be about lines. Identifying lines, which seems simple. Graphing them using a whole bunch of different things. Slope-intercept form and point-slope form, which hopefully you recognize those terms from pre-algebra. I hope we got there. Chapter 5, Lesson 1 is identifying linear functions. So a linear function is a function whose graph forms a straight line, and a linear equation is an equation of a line, particularly in the form of ax plus by equals c, where a and b are not both 0. Okay. Basically, you gotta have a y. You do not have to have an x. X is kind of sort of optional. You must have a y. You can't have exponents, and you can't have variables in denominators. That should all sound kind of familiar. So identify if the graph is of a linear function. Well, that's easy. Is it a line? Yes or no? And we can pretty quickly go yes, no, yes. Oh, wait, I wrote no. The reason I'm writing no, even though that is definitely a line, it is line. It's not a function. You got to think back to chapter 4, which we just completed. But a straight up and down line fails the vertical line test, which is how you tell if a graph is a function. Okay? So, line, yes. Function, no. Key distinction. Yes, it's kind of a trick question. Vertical lines are the only lines that aren't linear functions. So what happens if I give you a table? It says here, if there's a constant pattern of change, then the ordered pairs form a linear function. So let me show you what that looks like. From -2 to -1 is +1. From -1 to 0 is +1. From 0 to 1 is +1. From 1 to 2 is +1. Those are all +1, that's the same. This side is good. On the y's, from 7 to 4 is -3. From 4 to 1 is -3. From 1 to -2 is -3. And from -2 to -5 is -3. This side is all the same. That's good. The sides don't have to be the same. You can see here I've got +1 for the x's, -3 for the y's. That's fine. The x change must be the same. The y change must be the same. They are allowed to be different sames. I hope that makes sense. This is a linear function. In my next table, we've got the same thing. For the x's, we are constantly adding 1. So this side's fine. And the y's, 6 to 3 is a drop of 3. Okay. My iPad decided it wanted to freak out for a second. 3 to 2 is a drop of 1. 2 to 3 is an increase of 1. 3 to 6 is an increase of 3. That's not the same thing every time. So this isn't a linear function. And we've got a table here. So it's basically showing us that a linear function can always be written in that ax plus by equals c form I showed you earlier. And it's giving you 3 examples of things that aren't linear. And they're showing you the rules that can be broken. For the first one, x and y are multiplied, you can't have that. And for the record, I'm here. This guy has a problem because x is cubed. This has a problem because y is the denominator. Okay, those are basically the 3 rules you got to look for with equations. X and y cannot be multiplied together. You cannot have exponents. You can't have variables in a denominator. Identify if the function is linear, and if it is, make a quick xy table and graph it. Okay. Well, y equals x plus 3. X and y are not multiplied together. There are no exponents. X and y are not in denominators, so this is fine. Make a quick xy table. I'm going to use -1, 0, and 1 for my x values. -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4. -1, 2 is left 1 up 2. 0, 3 is stay in the middle, go up 3. And 1, 4 says go right 1 up 4. Line. I know the line doesn't look very straight. I'm drawing on an iPad. Last one, y equals x squared. X and y are not multiplied together, but x has an exponent. So this isn't linear. So we are not required to graph this one.